Hi there, this is video tutorial number 1 for the computer programming and numerical methods section of CENV1025. In this tutorial I'm going to show you how to construct basic functions in Python, and I'm also going to demonstrate some of the debugging capabilities of the Spider IDE, which we're using to develop our Python programs in. So in the first lecture of this course we covered primitive types and showed how we can do some calculations with primitive types straight in the Python console, like using a calculator. So for instance, if I create a variable called a equals 5, and then I use Python to inspect the type of this variable, Python has automatically assigned it the primitive type int. It's an integer. If I change a to be 5.2 and I repeat the type test, Python has, because I've used a decimal point here, Python has automatically detected and assigned it to the float type. And the other primitive types we talked about are string, which we can use for words, so if I do type this variable I called string, the type is str, which means that it's a string, and I can obviously print that string too. And then the final primitive type we talked about was the Boolean variable, which would be, if I say b equals true, you'll see that that's been highlighted a different colour as it's recognized the special keyword true. And then I go type b, it's telling me it's a bool. We'll talk a little bit more about why you're going to use that quite a lot in the exercise I'm about to go through, which is to build a few functions. So using basic numbers, we've already seen we can do some maths, some calculations here. So like let's do 3 times 4. So we can do basic calculations, we can do more complex things like times 12, and we can even do powers like that. So now we're going to try and actually use this capability we've got to do basic calculations in a more formal and structured way that you might find within a program, and that involves putting our calculations into functions. So I'm going to move over now away from the Python prompt to our text file, because all Python programs and computer programs in general are going to be written in text files, not via interfacing with the prompt. So we'll start by importing, if I can spell it correctly, importing a Python module called math, which is going to be very useful. That contains a lot of useful, we're going to be building functions, but we're also going to be using functions, predefined functions, and many useful predefined functions are in this module called math. So in order to be able to use it, we need to import it. So that's the first thing. Then I'm going to define a function called circle area from diameter. So notice how I've given my function quite a descriptive name. This is generally good practice, as it helps readers of your code understand what's going on, and indeed it helps you understand what's going on when you return to a piece of code you've written a few days ago. So we'll give this a single argument, d, which is the diameter of a circle, And what we want our function to do, we then put the colon and we return, and Spider automatically gives us this indent here, which is required by the Python interpreter to understand that what we're writing indented underneath this definition line is what actually happens in the function. So we've got def, the keyword that says we're defining a function, we create a name for our function, and then within brackets we list any arguments that we want to pass to the function, and here we've just got the single argument d. Okay, so then again, good practice is to create a little message in here which says what the function does. So it takes a diameter d and returns the area of a circle I'm going to specify there float with diameter d. I'm going to specify there that it really wants a float value. Okay. Oh, forgot to say what it does. And returns the area. Okay, so now we need to calculate the area of a circle from its diameter. So if we just create a variable called area, and we're going to use math now. So we're going to get math dot. We hit the dot, and then it tells us all the functions and things we've got within math, and the one we want is this one, pi, which is it just contains the value pi to a large number of decimal places, which is what we need. And in fact, if we go down to the prompt, we can, if I do math.pi, you'll see it prints it out. And we need to times that by the diameter squared. And we want that whole thing to be divided by 4. And notice how I've used a decimal place here to force 4 to be considered as a float, so that we don't get any bugs due to integer division. And then we just want to return that return area. Okay, so we can save this program, we can run this program, but nothing's going to happen because all we've done so far is define a function. And when you run a Python program, it doesn't really care much about functions that are defined. It only really cares about functions that are actually used. So if we want to use our function, we need to call it somehow. So probably the simplest way to call a function, I'll just copy the name to make it easier, is to use a print statement. So we'll print out the area of a circle with diameter 1. So now if I run the function, you'll see down here it's printed out a area. It's printed out whatever's returned from this function, which is the area of a circle with diameter 1. Okay, so now let's try a different function called circle area from radius. And we'll pass that a single argument called r. I'm going to make use of copy and paste here because I think my my description string is going to be quite similar. So this one takes a float r and returns the area of a circle with radius. Oh, I see what I've done there. Okay, silly me. I've got a big tautology in my description string. Let's get rid of that. Okay. So now what we could do here is we could then copy our equation up here and change it such that it's valid for a radius, but perhaps a more elegant way than doing the calculation again is to simply call our earlier function. So I'll show you how we'd solve it that way. So we'll get rid of that. Now really what we just want to return is the circle area from diameter, and we'll pass that 2 times r. So that takes our radius, multiplies it by 2 to turn it into a diameter, and then passes it to our previous function and just pipes the returned value from our previous function straight out as the returned value from this function. So we'll save it, we'll call it print circle from radius. Now if we give this a value of 0.5, we should get the same value as before. We should just get the same value printed out twice. So if I run this function, you'll see I've got the same. The first one's being printed out here on line 18, print circle from diameter, and the second one's being printed out here, line 25. Okay, so maybe now is a good point to just show you some of the debugging functionalities of Spider. So each time I've run this code, I've just pressed run, and had I done something wrong, we'd have got some error messages. Sometimes when you're trying to work out what you've done wrong, or if you just want to understand how the code is working, it makes sense to, instead of just running the whole code, to step through it line by line. And the way you can do that is using this this icon here, Debug File, or with the keyboard shortcut Control F5 you can do that as well. So if we run, we see this line, this first line of code up here, line 6, gets highlighted. And if we click step, then we just move forward one line in the code. So now we get to the import, and it imports the math module. Now we get to the definition of the function, and if we press step, notice how it steps over the entire function to this print statement, and that's because, as I said, Python doesn't really much care about function definitions when it's running code. It cares about functions getting called. So if we hit step here, we again just step over the print statement, and the value gets printed out here in the debugging window down here. And again, we're going to step over this function definition to get to the last one. And here what I'm not going to do is, instead of stepping over it like I did last time, I'm going to use this arrow here, which means to step in. So I've got a function being defined here, so something's going on within that function, and actually I want to know what. So I'm going to step in, and you'll notice the highlighted line jumps back up here to the function definition, and now when I press step, I actually drop in to the circle area from radius function, and I can proceed through that function line by line. But circle area from radius calls another function here, circle area from diameter, and again I can step in to that. So I drop into this one, and I can step, and I see we've got this area variable being defined here. And I can look over here on the right. This is also kind of useful. I've got this thing called the Variable Explorer. And if I step over that, you'll notice that something appears here called area with the value. So I can actually keep an eye, using this Variable Explorer window, I can keep an eye on which variables in my code are being assigned what values. And then that returns the area. And what's happening here is I'm being stepped into a lot of sort of internal Python functions there at the end with the prints. So there we go. That's a bit of debugging. So what I want to do now is just define one final function, which is going to be called circle area. So this is a function that I want to be able to calculate the area of a circle whether I give it a diameter or a radius. Okay, so to explain how I'm going to do that, I'm going to use another nice piece of functionality Python has, which is the ability to assign default values to your input arguments. So I'm going to say create an input argument called D, and I'm going to give it a default value which is none. And then I'm going to create a second input argument called R, and I'm going to give that a default value which is also none. So none is a special keyword in Python which literally means we can assign nothing to a variable. Now the reason I've done that is now when a user calls this function, they can give it either no variables, or they can specify the variable D or the variable R, and any variables that aren't explicitly given in the function definition, which I'll show you how that works in a minute, are assigned their default value, which in this case is none. Okay, so now what I'm going to do is I need to work out inside my function. I want it to have two different options. If the user's given us the diameter, I want to use my earlier defined function circle area from diameter. But on the other hand, if the user's given us the radius, I want to use that function. So I need to have a choice here. So this is where I introduce some control flow. Okay, oh, I must remember, of course, to make my documentation string. So takes a float R or D and returns the area of a circle with okay, so that's the plan. So now for some control flow, now what I want is an if statement. Now an if statement takes, following an if statement, you need to create another statement which can be evaluated as a Boolean. Okay, so in other words, it wants to be true or it wants to be false. Okay, now obviously if I just type true, that's a Boolean statement of a kind, but actually what I want to know is did the user of this function, did they pass it the diameter? And I'll know if they passed it a diameter because they'll have given it a value, presumably something other than none. So I'm gonna use this statement, which looks like this: if D does not equal none. Okay. So actually, just to show you how this kind of works, I'm going to drop down here. So this is a bit of Boolean logic here. We can use this statement to compare values. So for instance, let's say I create a value A equals 3 and B equals 3. And then I compare them. I can compare them using, for example, A does not equal B. Okay, so this is almost like a question. I'm saying, does A not equal B? And I get the answer false because A does equal B in this case. The opposite of that is to, of course, say, does A equal B? Which in here we use this double equals because here we're testing an equality, which is different from what we're doing here, which is assigning a value. So in Python and in computer languages in general, a single equals actually doesn't mean equals, it means assignment, and a double equals means equals. Okay, so that should return as true. And I can do is A greater than B. That's not the right symbol. I'm going to get false. I'm going to get false. But I can obviously do is A less than 10. That's going to be true. Is A greater than 0? So that's going to be true. So all these kind of statements can return true or false. Okay, so this particular statement is going to return true if the user has assigned something to D, or false if they haven't. So if it's true, that means we want to use our circle area from diameter function. And we'll give it the value d. Okay? And now we want another option, because obviously that takes care of the case if the user passed the diameter, but what if they passed the radius? So we use this keyword, elif, which is kind of short for else if, and it's exactly the same. So we have to pass that a statement that can be evaluated as a Boolean, either true or false. And now we want to return the output of this function. And it's good practice to always have a else at the end of these, because I guess we need to consider the possibility that the user didn't pass anything to our function, or maybe they assigned none to the values. And so there is a possibility which isn't catered for by these first two. These first two if and else if statements. So we need to finish off with an else statement, which essentially catches all the rest. So if something hasn't been caught in those first two traps, we just return none. Okay. Right, so let's see how that function actually works by calling it. So let's print circle area d equals 1. Okay, so we specified that we're passing the d, the diameter. And let's save this now. I'll show you another good trick about debugging here, is if I want to run my code, and I don't want to step through every line, I want to shoot forward to a line that I care about, I can double click on the line, and it adds this symbol here which signifies a breakpoint. It's called a breakpoint. So if I start debugging, again I get to this line, I can now hit this button here, this kind of fast forward, continue, the code will run until it gets to the line which I've added the breakpoint, and then it will stop. So there we go, we've stopped on that line. And I'm going to step in to the function, and I end up in the function I've just built, circle area. And I check my variables, and I see that I've got d equals 1, but I've got no r. So that follows what we've done here, which is assign 1 to the argument d. So hopefully d doesn't equal none, and if I go here, it's going to step in. If I just step, it's going to drop into this part. So it's going to drop in here to the return statement, and then it's going to return circle area from diameter. And that is that. So if I run the code, if I just run it here, we should see now, yeah, we've got the same number now printing out 3 times. Here, here, and here. Okay, so now if I change to the radius, we can do the same thing again. So I'll save that, I'll run it, I'll fast forward to our breakpointed line, I'll step in, and here what's going to happen, again, now I check my variable explorer, now I've got a value r equals 0.5 but no d. So now d should be equaling its default value, which is nothing, which corresponds with what we've got up here. And if I step, so it's going to bypass this bit of code in here, and we're going to apply this next test. Does r equal nothing? No, it doesn't, so we drop in, and then we run circle from radius, and of course again I could step in here and I end up in the circle from radius function. That drops us back to there. Okay, and if I just run the whole code, again we've got this same number printing out 3 times. Of course, if let's do the none case just for completeness, so I won't pass the function anything at all. Fast forward, step in, oh whoops, I stepped over, stop, abort. Let's try again. So run the code, fast forward, step in. Now, does D not equal none? That's false. Does R not equal none? That's false. So we end up in this catch-all return none. And we print the circles area. Okay, that's that. In the next video tutorial, I'm going to talk about lists and tuples.